Show that 2 cos x cot x plus 1 is equal to cot x plus 2 cos x. Can be written in the form a cos x minus b cos x minus sin x equals 0, where a and b are constants to be found. Okay, so let's just bring everything to one side. So 2 cos x cot x. So then we'll have take away cot x plus 1 take away 2 cos x is equal to 0. Now note there's no cot in this at all, so let's just think about that. So 2 cos x, cot x is cos x over sin x, and then the same here, cos x over sin x, plus 1 minus 2 cos x equals 0. Now let's just multiply through by sin x to get rid of those sin x's off the bottom. And then I'll have 2 cos squared x, take away cos x, plus sin x, minus 2 cos x is equal to 0. Now, what does that give me? That gives me 2 cos squared x. This one over here, forgot to multiply it, would be a cos x sin x. So 2 cos squared x, let's bring that up here, that 2 cos x sin x. And then we'll have plus sin x minus cos x, like that. So what can we do here? So we could factorize this term here by taking out a 2 cos x. And if we do that, then we've got cos x minus sin x. And then we could have a take away 1 here, and a cos x minus sin x from the second two terms. Just think about re-expanding that, you'll get these two terms. And so 2 cos x take away 1, cos x minus sin x equals 0. So that's because we could take out the common cos x minus sin x. And so we can say, comparing with the above here, that a is equal to 2 and b is equal to 1. So hence or otherwise solve this equation for 0 to pi, and you'll notice that the equation is just what we had up here. And so what we can do is we can say, well, that's 2 cos x take away 1 cos x minus sin x is equal to 0. And note that you could do that whether or not you could prove this in the part above. So you can still get these 3 marks here. So cos x is equal to a half, or cos x is equal to sin x. And dividing both sides by cos x here, that one gives me tan x equals 1. And all of these are standard angles. Cos x equals a half gives me pi by 3, and its partner would be down here, pi by 3. We're only looking for numbers for angles from 0 to pi though, so pi by 3 is the only solution from there. And this one's a standard angle as well, so we know that tan of pi by 4, and that one will be outside of the range that we want as well, so it's pi by 3 or pi by 4.